In topic 3, we're going to be looking at how to work with function notation. So in the previous topic, we looked at this function machine where we had the inputs going into the machine and then out popped the outputs. And in order for it to be a function, for every one input we put in, we can only have one output. So if we put in an input and we get two different outputs, as we have in the second example, it is not a function. So let's look at how to write functions as equations. So a function that is written as an equation can also be written in a form called function notation. So over to the side here, I have an example of what function notation is. So we have an f and then we have an x in the bracket. So how we would read this is we would say f of x. So the function of x is equal to x squared. So that's how we would say that out loud. So I would say f of x is equal to x squared. Now remember, x is the input. So our inputs up here are the x values, and then our outputs are the y values. So over here where we have f of x and we have this x appearing, that's where we put the input. That's where we state, okay, I'm going to input this number. And then over here is what we get as the output. Now this all looks a little bit confusing, but let's break it down into something that we actually know how to work with. So before this, you knew how to work with equations. You should have done that in grade 9. So here's an equation, y is equal to 4x. So if we were to write that equation as function notation, all we do is we take this y, and instead of writing y, we write f of x. And all of a sudden that equation is written as function notation. So really, whenever we see this f of x on a function notation equation, all that really means is y. So f of x is the same thing as y. So that's what I have written down here. The number that replaces x in f of x will tell you what value to sub in for x into the equation. And then think of f of x as y. Okay, so this over here is y. So let's actually look at some examples now. So for example 1, it says find f of 3 if f of x is equal to 5x. So they want us to find f of 3. So what we have to do here is we're going to write down this equation. So here I'll write f of x is equal to 5x. But now they want us to find f of 3. So I'm going to put f of 3. Notice how instead of x, we have a 3 written. So that 3 replaced the x. So if we replace the x with 3 on that side of the equation, we're going to do the same thing to the other side. So where this x is written over here, I'm going to put a 3. So now all of a sudden we have f of 3 is equal to 5 times 3. Therefore, if we continue with the equation, we would have f of 3 is equal to, well, 5 times 3 is 15. So f of 3 is equal to 15 is the final answer. So really, this is telling us what to replace x with in the equation on the other side of the equal sign. So whatever value they tell us to replace, we plug it in for x and then continue solving. So for b, let's see, we have find f of 4 if f of x is equal to 8x plus 2. So we have f of x is equal to 8x plus 2. And now we're going to find f of 4. So I'm going to replace all the x's with a 4. So we have 8 times 4 plus 2. And now if we continue solving, we would have 8 times 4, that is 32, plus 2. And then finally, 32 plus 2 is 34. So I just followed BEDMAS on this side of the equation. So therefore, f of 4 is equal to 34. That's the final answer. Moving on to example 2, we have a function is defined as f of x is equal to negative 0.8 x squared plus 2. Calculate the values of the following. So here they're giving us a bunch of different x values to plug into the equation. So let's start off with this f of 3. So f of 3 is equal to, so now I'm going to write this side of the equation, but instead of x, I'm going to put a 3 there. So I'm going to have negative 0.8 times 3 squared plus 2. And if I continue solving this using BEDMAS, I would do that squared first. So 3 squared is 9. Then we would have negative 0.8 times 9. That would be negative 7.2, and then plus 2. So negative 7.2 plus 2 is negative 5.2. So f of 3 is equal to negative 5.2. So in B, they now want us to plug in negative 10 for x. So we're going to do the same thing. Negative 0.8 times negative 10 squared plus 2. So now we're going to do that negative 10 squared first. Now remember, negative 10 squared, that would be the same as negative 10 times negative 10, which is equal to positive 100. Then that plus 2 at the end. Now we have negative 0.8 times 100, that's negative 80, plus 2. So our final answer is going to be negative 78. And then finally, we're going to do the same thing with this 0.5. So negative 0.8 times 0.5 squared plus 2. So then negative 0.8 and 0.5 squared is 0.25 plus 2. Then negative 0.8 times 0.25 is equal to negative 0.2, and then plus 2 again. So then our final answer is 1.8. So f of 0.5 is equal to 1.8. Now for example 3, there is a slight difference in the problems we're doing. So for A, let's see how this reads. It says, for the function f of x is equal to 4x minus 3, determine x when f of x is equal to 17. So there is a slight difference in the wording here. It says determine x when f of x is equal to 17. Notice how in the ones above that we did, it says find f of 3 or find f of 4. It doesn't say that in these ones. It says determine x when f of x is equal to 17. So there is a difference in these wordings, and there's a difference in the process we use to solve these. So this is not the same as f of 17. Okay, so these two are not the same thing. So let's see how we would solve these ones. So we have our equation, and I'm going to write it down here, but this time they gave us that f of x is equal to 17. So instead of replacing the x's with 17, I'm going to replace f of x with 17. So f of x is all right here, so instead of having that, I'm going to write 17. And then on the other side of the equal sign, it all stays the same. So all I did was replace f of x with 17. And now we're going to solve for x. So I'm going to isolate x, and this goes back to grade 9 when we have to get x all by itself. So I'm going to add 3 to both sides of the equal sign first. So we're going to have 20 is equal to 4x. And then finally, we're going to divide by 4 on both sides of the equal sign to cancel that 4 out and get that x all by itself. So we're going to have 5 is equal to x. And that there is the final answer. So notice how this time, in the final step, we have x is equal to something. We have x is equal to 5. But in these other ones we did, we have f of the number is equal to 15, or f of 4 is equal to 34. So there is a difference in the final answers and how they're written. But I just want to remind you that f of x is seen as y. So when we solved for these questions here, we're technically solving that y is equal to 34, or y is equal to 15. Whereas in this question, we solved x is equal to 5. So one, we're solving for y, and in the other, we're solving for x. So let's try again here. For the function f of x is equal to x over 3 plus 2, determine x when f of x is equal to 9. So determine x when f of x is equal to 9. So instead of writing f of x, we are going to write 9 is equal to x over 3 plus 2. And again, we're back to grade 9 math, isolating that x. So first I'm going to get rid of this plus 2 by subtracting 2 on both sides of the equation. So 9 minus 2 is 7. So we have 7 is equal to x over 3. And now we have divided by 3 on this side, so I'm going to times by 3 on both sides of the equation because that'll cancel that out. So our final answer is going to be 21 is equal to x. Finally, for example 3c, we have for the function f of x is equal to 6 minus 2x, determine x when f of x is equal to 38. So now instead of writing f of x, I'm going to replace it with 38. So we have 38 is equal to 6 minus 2x. So now I'm going to get rid of that 6 first, so we're going to subtract 6 from both sides of the equal sign. That'll cancel that out. So 38 minus 6 is 32. And then we have equal to negative 2x. And now we have to divide by negative 2 on both sides of the equal sign because that'll cancel that out. So 32 divided by negative 2 is equal to 16. So 16 is equal to x, and that would be the final answer.